Good morning, everyone. Very excited to be here. I was just telling the team that we got selected for Diatomic Digital Twin, and the announcement had gone last week itself. So, super excited. It's a very exciting space. So, today I'm going to be talking about what we have been building and how, as part of the digital twin technologies, we've seen that um, the whole technology is getting integrated, etc., and the value we are adding. Let me start by sharing my screen. Please let me know when you guys get to see my screen. Okay.
It's just coming through now.
Yeah.
It's not loaded fully yet. We can see, it's not yet in presenter mode. You just see the slides as is. Now it's in presenter mode and we can hear you. You're good to go.
Great. Thank you so much. So AI Gizmo Copilot for Planning, our very sweet and small motto, fewer revisions, faster decisions. Let me start by introducing the team who's working on it. Myself have been a second-time founder. I started a company called Machine Max, used to work with HS2 very closely. Some of people might know that. Some of people would have come across that name. Sold that company in 2024 and then immediately started working on AI Gizmo. The team I have with as my co-founder, they are very well versed in AI, product development, digital technologies, etc. And this is during Machine Max was my first foray into construction, right? So I come from a B2C product development background. And when I started working in construction, that just maybe it's, coming as an outsider perspective, you guys would have seen these numbers, like 80% of the projects are usually late and over budget, and there are hundreds of revisions per project, which happens, which result in lost time. There's a lot of reworks which happens, which again results in wasted money and obviously results in wasted productivity. So it's kind of, it always had this thing at the back of my mind that, there is a lot of improvements which we can do in construction. And I'm not, probably simplifying it to the simplifying it too much, but I understand it's a very complex environment and everything, having worked in this industry now for 6, 7 years on the technology side. But when we started diving deep into it, we started figuring it out. There is the complexity itself is because there are lots of things happening manually. And the more we started diving into it, we figured out that the more we move up the value chain, we were working in the execution side of the construction, right? Working with machines. The more we started looking into it, we started figuring it out even at the start when the policy or the urban planning or the site planning starts. From the very beginning, there are lots of static document, PDFs, words, which are not machine readable, which itself causes a little bit of issues from the start itself. The revisions are takes a lot of time because of the manual. There's no automation or very less automation. There's a lot of ambiguity because the data is fragmented data sets. So when we started speaking to designers and urban planners, we saw that there are multiple data sets like ONS, Trix, DEFRA, RICS, and these are having very siloed or very like a manual kind of a PDF kind of a not digitized approach. So teams are also siloed. There's a lot of back and forth which happens, and there is a dependency on consultants as well. So what we saw is a typical workflow can take up to 20 to 40 revisions, 30 to 50 revisions in scenario modeling and impact assessment side of things. And that turned out to be catnip for agentic AI or generative AI. Generative AI was just started to explode in November 2002. 2022 is when we saw that chat OpenAI exploded suddenly, and that's and the whole Gen AI and agentic AI started to come into the mainstream. We've always been working on machine learning algorithms, so it became a catnip for us that all the static documents, all the issues which are currently available, essentially can be utilized through agentic AI, and they can be automation possible. So what you see here is we ended up building a copilot which ingests GIS, zoning data, transport. So all the data sets which were fragmented, we combine it, we integrate it together, including even the IFC files from BIM. Obviously, there is a local context which is needed. So, for example, when we are working with Green Innovation Corridor team or Wolverhampton Council, they have provided us a lot of local data as well. Our agents runs the planning scenarios and policy constraints. So all the things which was supposed to be done manually are now our AI agents have started to do it, a specific task, and there is a specific agent across. We also explain why a specific scenario is passing or violating rules, etc. So there's a lot of explanation which goes behind it. And then at the end, the outcome is that we have a decision ready narrative in real time plus evidence, which in turn helps reduce the decision cycle through automation, cut the revisions, cut the reworks, and unifies the workflow. How does that look like? It's a chat-driven command layer, and I'll show you the UI as well, user interface in a incoming slides. A designer or urban planner uses a natural language, and there are, like I said, there is a layer of specialized agents, and there is a agent orchestration which happens at the back, which helps do those tasks and in turns automate the workflows and digitizes the data. So I've written it and this presentation would be shared. So if you have any questions further on any specific agents, happy to answer that. This is a typical agentic AI architecture. Looks like what we are using is the machine learning side of it. So there is a RAG, deep learning, which we are doing image recognition, or there's a computer vision part of it, which is more we are using it natural language processing. Like I said, there's a lot of decision making which has been happening, and obviously simulation, system behaviors, and performance through modeling. So what does a typical AI agent architecture looks like is there is reasoning driven by LLMs, large language models. In many cases, we have taken up a large language model, trained it onto the policy data, and made it a small language model, right? So for the very specific projects and everything, we turn it, we use a small language model, which helps us plan, helps our agents plan, provide the reflections, criticism, context of what the agent's supposed to be doing as a task. And there is an input which is coming through a chat interface. I put this image there. Just many people would know that what's the difference between a typical LLM workflow versus an agentic AI. And if you look at a digital twin, it itself is quite strong in terms of data integrations, visualizations, simulations. With the use of agentic AI, we are adding the intelligence layer, adding context there, adding reasoning there, adding real-time, resolutions there, and making it more intelligent. This is a chat-based interface, which a policymaker or a planner gets it. You can see it's a very simple UI, deliberately kept it simple to keep the cognitive load low, which was one of the things which was coming in from our research a lot. So the planner inputs, there are pre-prompts as well there on the user interface. Otherwise, the planner can use a natural language way. And these are the agents, if you see here, policy checkers, scenario builders. And what do they look like is a typical policy checker AI agent, which goes ahead and when a policy has been uploaded, will go back to the data sets I mentioned or the constraints which I mentioned, and results in any kind of conflicts which are arising or any kind of against the policy framework, will provide the details of that policy. We visualize that on map, so it's very easy for a person to see the impact. A typical scenario builder agent will have various tasks. It could be against density, land use mix, transport, or green, percentage of green, or flood areas or heritage areas. So there are certain constraints which are there. We usually start with 3 to 5 scenarios, and multiple scenarios can be built in, but we provide 3 to 5 scenarios based on the project. And again, the visualization is there on the map to see the impact of those scenarios and also compare those scenarios. If I have to use 15% green space, what would it look like? Do I need to have, or let's say affordable housing, there's a 40% affordable housing which is needed to be there as part of the projects. What would it look like? And we can visualize those scenarios with the help of scenario builder and compare AI agents. We also go into the deep of any specific scenarios, impact, and like I said, we provide the evidence. So you see here, you can go back in the timeline and see what had happened, and that's the evidence and the audit trail, to keep track of the complex scenarios which has been given. But if something has chosen, what was the reasoning for it is being chosen, etc. This is again in the backend side of it, there's an agent orchestration layer, specialized AI agents which are there, which are working on models. And so if you see here, there is an input layer, which is usually from our data streams or natural language processes or any PDF documents which has been uploaded. We have built the orchestration layer on top of it to make sure the AI agents they are not siloed, and there is an orchestration happening between the two. And the AI agents itself are doing specific tasks, and then they are providing an output which is very tailored, knowledgeable, and contextual. We have put a lot of emphasis on safety and security, which goes without saying. We've been, working in a B2B environment, working with the data we are working on. Even with the team we are working here in the Diatomic, there is a lot of emphasis in terms of using Microsoft Azure, Foundry, SSO, all sorts of validation authentications which is needed to be done. And we also go back and look at the results which are coming out of the prediction results and keeping the accuracy as high as possible there. So the results is, the number speaks for itself. The initial results are very encouraging. We can reduce the cost up to 50%, less than 50% in many cases. A typical time spent on a workflow in terms of revisions or reworks can be in days and hours, but depending on the complexity of the project, it can, again, from 4 weeks, it can come down to 2 weeks, and the accuracy improves 95% because things are automated. The machines or the agents are doing specifically doing the task, etc. So there is accuracy and the quality. And this is my last slide in terms of what the AI Gizmo intends to do. We want to automate the industry with AI agents. We want to provide a one system of record for all decisions so that we can improve quality and accuracy, ultimately saving time, money, and resource costs. Thank you so much.
So our first question, if I may, is what did you learn from this and how would you do it differently?
Wow, a lot of learnings. In terms of understanding that how, the complex the planning itself is and why it is complex, there's a lot of learning which goes in. But for me, I think the biggest learning is people are there, eager to look for solutions, and these are the fragmented systems, and the siloed systems are the one which is stopping them in many ways. There is so much of eagerness from people itself. It's just that the system itself is a constraint. So if I have to do something differently, looking at solving that system problem, that's where I would start. Because I think people are very eager to make this work.
Very good. Thank you. Our next question, if I may, is in engineering projects, compliance design and production/implementation/construction is what takes the most time and requires the most human input. Bureaucratic and financial steps such as outsourced consultancy workflows and approvals could be improved. Have you done much improvement on the former of those?
So in engineering projects, compliant designs and production implementation. So yes, we are working with BIM on that. So this is like, for example, I completely agree with this, that, there is multiple versions, there is multiple iterations which happens, and creating that single source of truth in terms of figuring that out. And again, it goes back to fractured data, like, because there's a lot of input needed as well. There's architecture working on it. There's a planner who's working on it. So one of the things is BIM IFC files, which we've started to ingest. So we've just started to look into it. So I'll be happy to share what we find as part of this whole process. We are working with GIC and we are working with Wolverhampton Council. And one of the key things which we are facing right now is getting those files, those itself like huge data sets. So I'm happy to share my findings once we come across, but we've started to look into it.
Very good. And what are the biggest challenges with your solution in terms of the quality of data in their paper/PDF planning documentations and the map images, and how are these being addressed?
Static, yeah. So maps are quite static. It's not as dynamic as you see in Google Maps, like things like that. So there is the whole issue is there is the legacy systems or the use of. I think the quality of data what we've found in general is pretty good. The data what we have got from our pilot projects, very specific data, and the good quality data. I think it's the relevance of that data. Like when you're working on scenarios, we have to think about like demographic effects in let's say in 5 to 10 years, right? And what how will that impact today's development which is happening, or in real time, not even going 5 to 10 years. So that staticness of the data is something which we struggle with. Quality of data in general is good, and I don't know we have addressed it yet. We are trying to get it more dynamic as much as possible, but I think we haven't addressed it yet.
Very good. Thank you. Next question is, I'd like to ask if you're truly using agentic AI, for example, autonomous workflows to decide, plan, act towards goals with no human intervention, and not AI copilots to help users interact with the system, draft content, answer queries, or etc. So I guess the difference between AI agents and AI copilots.
Yeah, no, we are definitely, we have specific, like if you've seen our architecture slides, they are AI agents who are actually doing the work, doing the tasks, and then we have created the orchestration layer. There is definitely human in loop in terms of figuring it up. We are not letting the agents, because these are still in the initial stages, we're not letting the agents go ahead and complete the task. There's definitely a human in the loop to make sure that it confirms and then that happens. But we are using agentic AI.
Very good. Are there any other solutions out in the wild which you think would augment your offerings? I'm thinking of things like 3D building models or end usage profiles.
Yeah, so we are working with data centers. Surprisingly, there is a lot of anywhere where there is a simulation or scenario modeling needed, we can use. I mean, and there is static data or things which are complex. We can deploy our system there. We're working with data centers here in UK, and there is an angle of energy usage. I haven't yet started looking into it, but yeah, there are multiple areas where we can deploy our solution. But we are starting with urban planning, and we want to make sure that coming at least for 1 or 2 years, we get this problem solved through of the urban planning and the site planning first.
Very good, thank you. So what other areas or problems do you think your solution could be applied to?
I think I kind of answered that, but wherever there is a scenario modeling simulations needed, we are looking at construction only right now. But for example, we got an invitation from life sciences, right? There is a lot of HIPAA or things which are compliance related things which happens in pharmacy or life sciences, and we had to say no because we said okay fine, let's look at. But yeah, there are multiple areas where we can look to solve wherever there is complex multiple documents, complex scenarios is needed. It's got text heavy or again I said like complex scenarios, we can deploy our solution.
Thank you. And our last question we have here is, could you explain a bit more about the trained small large language models that you use behind the GUI, and how you trained it and which large language models you used, for example, Gemma, DeepSeek, others?
Yeah, so we started with initial days when we were doing research, we started with open source, but right now we are working with ChatGPT 5. We have taken up a model, and we and Gemini as well. We looked at both. I think what we have done is, and my CTO would be better to answer this, but what we have done is we've taken up a Gemini model, trained specifically, did it on our local server, trained very specifically around zoning laws, etc., on the West Midlands, and made sure that it is working and it is understanding that, and then that's the one which we are going to use for GIC.
Perfect. Thank you. How do you know that the AI outcomes are correct? Have you verified the outcomes independently?
Yes, we do. During our research phase, the way we work in, or the way we have developed our MVPs, we looked at the manual workflows independently, like and then what's the outcomes which are coming. Like I said, it's 95% accuracy is there. In some places, we have obviously seen some, and we want to make it as accurate as possible. And it depends on, like, data, contextual knowledge. A person who's been in urban planning would have more contextual knowledge. The more we train our models, the more equipped it will be. We have independently validated it. So we've done that, and we would continue to do that.
Very good. And the last question here is, how difficult is it to set up agents and copilots, and what would your tips be for anyone who wants to start creating one?
So we are not using Copilot as in Microsoft Copilot. It's slightly, the term what we have used is Copilot to explain that it will be a Copilot. It's the English word of Copilot, not the Microsoft Copilot. So what we have used is RAG, Python, and so the development is pretty much the standard development. It's just the name itself has caused confusion. It is having a domain knowledge, getting a problem, which is a typical case in any startup. You need to understand what the problem you're solving. If actually the Gen AI and the agentic AI would be useful to solve the problem, or it can be done in, with different. So my answer is the typical standard answer, that you need to understand the problem, look at the solutions, to take a double diamond approach, and then establish it. Apologies if Copilot made confusing for everyone.